It's a pleasure to be here, and I'd like to thank Marco Panza and his colleagues for inviting me to be here for a period a little longer than this particular workshop. The present essay proposes to deal with the claim that mathematics is primarily about concepts and thus only secondarily, if at all, about objects. I will, along the way, comment on some writings of two people who've made statements amounting to this claim. Donald Martin has been quite explicit about it. He says in an unpublished text, "I share with Kurt Gödel and Solomon Pfefferman the view that mathematical concepts, not mathematical objects, are what mathematics is about." In the second, that essay, the later of two bearing on this theme, no, I'm sorry, not that essay.
Are there more handouts?
Yes. Yes.
In the second of two essays that bear on this theme, Daniel Isaacson speaks of structures rather than concepts, but the issues he raises are at least closely related, and in an earlier paper, probably better known, Mathematical Intuition and Objectivity, published in a volume in 1994 called Mathematics and Mind, concepts are more prominent. The claim contains three elements that could give rise to problems: concept, object, and about. And each of these has been studied by philosophers, although about has been a stepchild. The writers who've advanced the thesis with which I'm concerned seem prepared to use the term about in an informal and rather naive way. And I don't have anything better to offer, so I will follow them in that. There are some more systematic studies about the word about and what how to characterize what a statement or a body of statements is about. I haven't gone deeply into that, but ideally to have a full study on this question, I should. The manner in which I've looked at the question is roughly as follows. It should be obvious that mathematics is in some way about objects because reference to objects is embodied in singular terms and first-order quantifiers. I don't think that any alternative to viewing the informal language of mathematics in that way has gone anywhere. I suspect that in the end, neither Martin nor Isaacson contests that statement, and their point is apparently something else. One might view them as offering skeptical arguments or puzzles about mathematical objects, and I'll make a couple of suggestions along that line. The question whether and in what sense mathematics is about concepts is not so straightforward. In the first instance, it would depend on whether the language of mathematics contains reference to concepts. Assuming that it does, one then has to ask what is the significance of that fact. At this point, one should distinguish between the informal language of mathematics and the regimented versions reflected in formal axiomatic theories. Maybe not necessarily fully formalized, but so by informal, I mean not regimented or formalized. I'm emphasizing the case of regimented language because it's more tractable. The most standard formalizations of mathematical theories are first order. So, as already noted, the language involves reference to objects. Of course, there are many second-order theories discussed by logicians, but in the mathematical context, it's typical to take the second-order variables to range over sets, subsets of the domain of the first-order language. On this understanding, these theories can be expressed in the first-order language of set theory, so that the second-order variables simply range over the power set of the domain of the first-order variables. That's putting aside the difficult question how to understand the second-order language if the first-order language is supposed to, the first-order variables are supposed to range over absolutely all sets. But for most purposes, we can take the first-order language of set theory as the appropriate example of a regimented mathematical language, which usually has the primitive predicate of membership, no primitive singular terms. But because even minimal axioms imply the existence of some sets, we can presume that it involves reference to mathematical objects, namely sets. How much my two authors want to question that, well, I'll give some information about that. A more urgent question is whether the first-order language makes reference to concepts. The vehicle of such reference would most likely be the predicates of the language, and two eminent logician philosophers, Frege and Gödel, have developed views according to which predicates as such designate concepts. I'll mention some differences between their views, but what's most important is something that they have in common. That is, that for them, concepts are not essentially mental. They're objective in a sense stronger than being shared by different minds. Martin, well, no, I better not say that. In this respect, Frege departed from a tradition that can be traced back at least to Kant, according to which concepts are a species of representation and are thus contents of the mind. Exactly what contents means would differ from different philosophers in this tradition. In Kant's view, they may still be objective, but where this is so, it's by virtue of the fact that the individual mind has a basic structure that is common to all human minds, and possibly even to some purely hypothetical non-human minds. Frege's departure from this tradition is clearest where he introduces his mature views in writings of the 1890s. The notion of concept is explained by a mathematical analogy. Concepts are characterized as functions in roughly the mathematical sense, but which can take only two values, the true and the false. The truth values that are now familiar in elementary logic. If we ignore his disastrous basic law 5, his logic is a version of second-order logic, which is familiar today. And he takes the second-order variables to range over functions, and in many important contexts, these will turn out to be concepts. So predicates, even logically complex ones, have concepts as their reference. Well, I don't need to go further into Frege on functions and concepts. I think that's familiar. I'll just say that he didn't single out the first order part of his logic, given his view of predicates as designating concepts, it would probably have seemed perverse to him to renounce variables and quantifiers for concepts. Well, Frege's logic seems to embody a realist view of concepts. Gödel didn't articulate a theory of meaning and reference on a level with Frege's, and of course, in a lot of his work he worked with first-order logic. But he expresses a realistic view of concepts in his first published philosophical essay. That's, quote, well, there's an error in the numbering. This is text 1, but it's the second one, numbered 1. I won't read it because I think it's fairly familiar. Gödel, in contrast to Frege, thinks of concepts as a species of objects. That's the view of his published writings and other essays written in the 1950s and 60s, but he may have come to question this in the 1970s, where the reports of Hao Wang are almost the only evidence we have. But this evidence doesn't indicate what manner of entity they are if they're not objects, or call into question realism about concepts. It was his view that even rather elementary predications involve reference to concepts. And so it was certainly his view that in the first-order language of set theory, predicates designate concepts. Frege, of course, thought of concepts as extensional. Gödel, at one point, seemed to allow that they most might be, but that pretty clearly wasn't his later view. In his paper, Gödel's Conceptual Realism, Martin evidently shares the conception of concepts as essentially non-mental, and he's sympathetic toward Gödel's view. Where he gets off is at Gödel's version of mathematical intuition, of which perception of concepts is an integral part. But I'm not going to go into that subject. In this unpublished paper, Completeness or Incompleteness of Basic Mathematical Concepts, he's more reserved. He mentions the view of Solomon Pfefferman that mathematical concepts are human creations, which he doesn't accept. What he says is, quotation 2, I would say I stand between the two, namely Pfefferman and Gödel, but in fact I don't have anything to say about the ontology of mathematical concepts. I do think it's more correct to say that they were discovered than that they were created by us. I've noted that these conceptions of concepts depart from a tradition going back at least as far as Kant. But to forestall confusion, I'm going to mention a different conception of concepts whose departure from Kant is a little more, at least more subtle. This might be called the Psychologists' Conception. According to it, concepts are mental representations and would naturally be taken to belong to individual minds. Thus, the psychologist Susan Carey writes, concepts are mental representations. They may, however, be intersubjective in that they might be shared by different subjects, possibly even common to all human beings, as would be the case for innate concepts if they exist. This conception of concepts or something similar is quite widespread also in philosophical literature. What can we say about another view of concepts that seems natural when one thinks about Frege, namely that they belong to the realm of sense? That's not the way Frege uses the word concept, but I think his writings naturally suggest that one might use it that way. That could be a version of the psychologist's view, but it doesn't have to be. Frege says very little about the senses of predicates, but in general, he doesn't think of senses as in the mind and distinguishes them sharply from what he calls ideas, which belong to the individual subject. The German term is Vorstellung, which of course was used in a much more general way by Kant and many other writers. According to Kant, concepts would count as Vorstellungen. That illustrates the fact that conceptions of concepts along lines from the Kantian well, no, I better leave that out. I haven't canvassed all the difficulties that these different conceptions of concepts might be subject to, but I think many have been brought out in philosophical discussions. But they that does raise the question about the thesis that mathematics is primarily about concepts rather than objects. Is it really the case that the notion of concept in application to mathematics is better understood than the notion of object? Well, I'd regard that question as a warning sign, but of course I can't say that it's an argument. With respect to regimented languages like the first-order language of set theory, the view that predicates designate concepts in any of the senses I've mentioned has to compete with a more nominalist view, which distinguishes sharply between predicates and names and denies that predicates stand in a naming-like relation to anything like concepts in the sense of Frege or Gödel or even more garden variety entities like properties and relations. Such a view can be found in the writings of Quine, held, I believe, virtually throughout his career, unlike the more strict nominalism, which he clearly gave up before about 1950. On this sort of view, the meaning of predicates is in the first instance explained by saying what objects they're true or false of. Now, a semantical account, even of first-order language, typically associates entities with predicates. In the most straightforward case, classes and relations. But this typically arises when we want to generalize, either over languages or over interpretations of a particular language. If we accept an inductive definition of truth, satisfaction and truth for a single language can be introduced without any added ontology, provided only that the object language already has finite sequences of elements of the domain. This is a technical matter that's exploited by Donald Davidson in his conception of a theory of meaning or interpretation. It also makes it possible for set theorists to understand talk of proper classes as ultimately reducible to talk about predicates of the language of set theory and sequences of sets. So that variables for classes in the object language are, for most purposes, not essential. Well, I think I'll just put aside the question of second-order languages when the first-order variables are supposed to range over all sets. Well, my comments have been focused on regimented languages, particularly of formalized language, mathematics, and in particular set theory. Without having made a systematic study, I think that in informal, unformalized mathematical discourse, reference to concepts is fairly common, not limited to the rather basic concepts that are emphasized by Martin and Isaacson. The case may be of a concept being discovered. Well, you recall Martin talked about a concept being discovered. It was mentioned in Jean-Pierre Marquis' talk this morning. What is it? Triangular categories. It does seem, but curiously, I can see good reasons for saying that that concept was discovered, but also reasons for saying that it was invented. And I think that's probably true of many mathematical concepts. Well, thus far I've said nothing about the considerations that my two authors offer in favor of the primacy of concepts, or possibly structures, over objects. I'll begin with Isaacson, partly because in places he invokes rather well-known philosophical arguments. I'll state at the outset that he defends a structuralist view of mathematics. I've pursued that project as well. But a difference between us is that I tried to develop a structuralist view of mathematical objects, and I think many of the other sort of well-known structuralist writers have also been trying to do that. I hesitate to say that of Isaacson, and that may be the reason for the, I think, very deplorable omission of his 1994 paper from the discussion of structuralism in the philosophical literature, for which I have to have some responsibility, since I heard the lecture was based on, read it back in those days. About mathematical objects, he makes some rather extreme remarks. Quotations 3 and 4. Nevertheless, these arguments, famous arguments of Paul Ben-Asaraf, in What Numbers Could Not Be and Mathematical Truth, do show that even if mathematical objects exist, their existence can play no role in answering our motivating questions. One might, by Occam's razor, conclude that they don't exist. That's from this later paper. And his second remark, it might be claimed that the account I've just given doesn't succeed in avoiding the primacy of objects. After all, my condition for a thought to be mathematical was that it be invariant with respect to change of objects. In saying this, I may appear to have slipped into object Platonism. That's a view that he argues against in this paper. Such an appearance reflects a source of the natural tendency toward object Platonism, namely that mathematical concepts are concepts of objects. The paradoxical sounding truth of the matter is that mathematics is about objects, but at the same time there are no mathematical objects. Now, that last remark might be an expression of some kind of fictionalism, but I don't think that's what Isaacson had in mind. I think what Paul Benacerraf dramatized in his famous paper, What Numbers Could Not Be, has to do with the different alternatives for construing numbers as sets, and after a lot of water has gone over the dam, one might read that and say, well, so what? But I think there is a more general phenomenon, which I think is what was driving Isaacson, what could be called the elusiveness of mathematical objects. If you try to state what object you're referring to in a, at least a modern mathematical context, it seems you can best give an answer that is internal to some home structure. Take the simplest case, the natural number. You're asked, you talk about the number, I don't know, 15. You're asked, what's that? What are you referring to? The answer you would normally give is quite internal to the system of natural numbers. It's the one that comes after 14. Well, what's that? It comes after 13. And then if you follow that route, you get back to 0, let's say. And in some cases where the relevant structure has non-trivial automorphisms, you can't even do that. You can, at best, state relations to other objects in the structure. Take a case that's appeared in recent literature about the complex numbers. Suppose you talk about I, the square root of -1. Then someone points out that -1 has 2 square roots, I and -I. But since there's an automorphism that exchanges them, are you sure that you've got a handle on the real I rather than -I? And perhaps the correct answer is there really isn't in some more ultimate sense, a real I as opposed to -I. Well, to go back to Benacerraf, he concludes that numbers are not objects, but doesn't mean that numbers are entities of some other sort. Rather, he suggests very briefly a program of eliminating reference to mathematical objects, which has been carried further by others. The second paper argues that if we understand mathematical languages involving reference to objects, then we have no understanding of how we can have cognitive access to them. much ink has been spilled about this issue, and ways of understanding it have been proposed that are quite different from Benacerev's original one. However, to go back to Isaacson, his remarks actually make me doubt that these questions, and even the radical view expressed in the quotations, express his considered view. The most telling reason for doubting that, I think, is quotation 5. I accept that works of fiction exist as abstract entities, so why not also numbers and sets? The point is that an individual natural number, e.g. that long one there, exists only through its determination by the categorical theory of the structure of the natural numbers. It has no independent existence. One can paraphrase this remark as saying that individual natural numbers exist only relative to the structure of natural numbers. They would be an instance of a view of mathematical existence that was expressed by Paul Bernays more than 60 years ago in saying that they have relative existence. His term was bezogene Existenz. Although Bernays didn't put Isaacson's stress on categoricity. That would imply that Isaacson's real intention is not to reject mathematical objects altogether, or even to say that it doesn't matter whether they exist, rather to insist on the priority of structures to the objects that reside in them. All right. This makes his denial that structures are mathematical objects make sense, since on the view in question, if a structure is a mathematical object, it seems that then there has to be a superstructure for it to reside in. In some cases, such as the number systems, candidates to be such a superstructure are at hand. There may be an inclination to view the natural numbers as more autonomous. But, however, in the case of the full universe of sets, although we regard it as, assuming that we regard it as well-defined, doesn't seem to be any higher structure to be the home of the universe as a structure. At one point, Isaacson suggests that structures aren't objects at all. I have difficulty understanding that sort of claim. If not, what else are they? He doesn't say that there are no structures, or that talk of structures is a façon de parler. If he takes seriously Benacerev's problem about cognitive access to mathematical objects, why isn't there a similar problem about cognitive access to structures? One possible reading might be that structures play a role for him close to the one that concepts play for Martin, and to guess that they're akin to concepts as conceived by Frege, but I'm pretty sure that Isaacson doesn't say that in print. Well, I want to turn to Martin. Time is probably getting on. He's mainly concerned with concepts of basic mathematical structures, such as natural numbers, the natural numbers and their subsets, and the universe of sets. The main contrast is with concepts of kinds of structures, such as groups, fields, metric spaces. In more than one of his writings, Martin has expressed doubt about views of mathematics that he calls object-based. I'm not sure exactly what he means by that. He doesn't show sympathy for nominalism, although he does suggest that pure mathematics can anyway do without objects. I think Martin's embrace of the thesis that concepts are prior to objects is like Isaacson's, based on difficulties he finds with mathematical objects. In the completeness or incompleteness theorem paper, the primary difficulty is based on the Gödelian idea that some statements are implied by a basic concept while others are not. You can read that in quotation 6. Note the last sentence. I take the question to be a meaningful one, whether or not there are any structures that instantiate the concept. Exactly what the kind of necessity is, I think, is not entirely clear, but I think in an ideal case it would be somehow logical. About the concept of natural number, he says that it's first order complete. That is, it determines truth values for all sentences of first order arithmetic. But he's inclined to the stronger view that the concept of natural number is fully determinate. It's determined in full detail what a structure instantiating it would be like. Not just in the sense of being categorical, but basically determining the truth value in some canonical language for this structure. He's not convinced that this property implies that it's instantiated, that is, that there really is a structure that answers to our concept of natural number. But he admits that he doesn't have an argument against the claim that any fully determinate concept is instantiated. Martin's claim of the priority of concepts and his effective skepticism about mathematical objects rests primarily on a puzzle he poses about the concept of the universe of sets. On the basis of an argument originally advanced by Zemelo, Martin argues that, at least up to a certain rank, the concept of the universe is categorical. He endorses an extension of the argument that would make it fully categorical, but that's not needed for the puzzle. Let's not make the weak assumption that categoricity obtains for an appropriate theory of V omega plus 2. In other words, a domain that would include all the hereditarily finite sets, all their subsets, which would correspond roughly to real numbers, and then all the next level of subsets, which would correspond to sets of real numbers. then any models that in Martin's language meet the concept of set up to that point will agree with respect to third-order arithmetic. The universe of sets up to that point, we're assuming, is unique. But then it follows that models will agree with respect to the continuum hypothesis. Martin insists that he doesn't have a firm view about whether the continuum hypothesis has a determinate truth value, but this argument seems to imply that it does, and I think has been read in that way by some earlier writers such as Krause. Martin doesn't accept the conclusion, but his reason is that he questions a premise of the argument that would imply that, namely that the concept of the universe of sets is instantiated, or even what's in effect the concept of a standard model of third-order arithmetic is instantiated. He holds that it's not essential to pure mathematics that this concept should be instantiated. He has no objection to the claim that the concept of natural number is instantiated, although he thinks that's not essential to pure mathematics. Now, to get back to set theory, my voice seems to be collapsing. I don't know what's going to me. Instantiation of the concept of the universe of sets, as Martin understands it, is a strong condition that there should exist a system of objects, call them sets, that constitute a maximal universe, in particular containing the full power set of each set and having an absolute infinity of ranks. Although the second condition isn't at issue when we restrict to third-order arithmetic. We should be clear what non-instantiation doesn't imply. It doesn't imply that there are no sets. It clearly doesn't imply that a weak concept, such as that of the hereditarily finite sets, isn't instantiated. It doesn't even imply that there are no models of first-order set theories, even with very large cardinals, since it's well known that they can differ with respect to continuum hypothesis. I think this is an important point because one can view the universe of sets with the maximality properties that Martin emphasizes as a transcendental idea that is part of many set theorists' conception of what their subject is about. But what they work with on a day-to-day basis are first-order theories, ZF, and its extensions by various other axioms, especially choice and large cardinal axioms. And extending these theories by going to second-order logic gives no deductive power not given by an additional large cardinal assumption. Now, it has been questioned whether the categoricity theorems can be taken at face value. It's certainly now known that the power of the logic needed to prove them is much less than casual accounts would lead one to believe. For example, if you take the natural numbers, Dedekind's theorem can be proved in what's called WKL0, weak Koenig's lemma. It's a result of Simpson and Yokoyama. And also in the case of set theory, one can greatly reduce the power of the logic that's needed to prove it. The main point is that you need, imagine you have two instances of the universe of sets. You need to be able, from the point of view of each universe, to look at the other. And that is, of course, is what the standard first-order theories don't allow you to do, because they just basically, the schemata only involve predicates in the language talking about the one structure. Well, I think maybe I better not pursue that further. There is another reason for being possibly skeptical about what these arguments prove, because it's possible to step back from it and view the proof as internal to some framework that could be otherwise. For simplicity, take two hypothetical natural number sequences, give an argument that they're isomorphic, but reflection on the language in which it's conducted would bring out that the language in which the argument is conducted is subject to non-standard interpretations. So from the point of view of the meta-language, you might say they could be non-standard. I don't want to express a verdict about that. I describe Martin as posing a puzzle. About a hypothesis like the continuum hypothesis, the set theorist has three options, none of which is entirely appealing. He must admit that either CH has a truth value, even though we may not have any means of deciding it, or he must decline to take the categoricity arguments as proving what they seem to prove, or he must, with Martin, say that the full concept of the universe of sets might not be instantiated. Martin doesn't use this term puzzle or the stronger term paradox. And well, you see his comment on it in quotation 7. He rejects a conclusion that we can be sure that there is a truth value. He is convinced about existence, but he wants to say that the full concept of set might, for all he knows, not be instantiated. Well, I think when I presented this material at UCLA, I suggested that he was comfortable with the conclusion that the concept of the university of sets was not instantiated. In later correspondence, he said he wasn't, but I think and that it did worry him that the continuum hypothesis might not have a truth value. It doesn't, so far as I know, comment on the possibility that it might have a truth value, but have one that we could never know for some reason or other. So I don't know what he thinks about that. No, this is going on and on. I think I probably... I think he has a view of mathematical truth that doesn't depend on the existence of objects. I think, by the way, that he really does accept the reasons that I've very briefly suggested for saying that the language does involve reference to objects. But what's true or false is what is implied by the concept. And that, I think, is supposed to work so as to bypass the existence of the object. He's following Gödel, I think, in giving this importance to the question what's implied by the concept. Gödel is not very clear about some of the issues that Martin discusses, and whether, for example, axioms to which we don't have anything like a priori instances might still be, in Gödel's language, implied by the concept of set. Well, I think I'd better bring this to an end. The upshot of my discussion is that he's quite happy to operate with a conceptual scheme in which mathematical objects have a place. I don't see how he could do otherwise without recasting mathematical language in a way I think we don't have a real idea of. But he thinks that mathematics, or at least pure mathematics, can do without supposing that they exist. I would maintain that he's asking too much of existence. I fear that without wishing to do so, he might put himself into the company of fictionalists who maintain that reference to mathematical objects is like references to persons, places, and other entities in works of fiction. I don't believe he wants to go there, but I'm not sure what alternative he envisages. He did write after, in correspondence with me, that he is quite bothered by the possibility that the continuum hypothesis might not have a truth value. But he doesn't think, even though that would imply that the full concept of set is not instantiated, He doesn't think that set theory as a branch of mathematics would collapse because there are still meaningful questions about what's implied by the concept that can be investigated and, of course, are being investigated. Well, I better stop.
This is a very elementary question. I find myself somewhat puzzled about how Martin and perhaps Isaacson also are thinking of concepts as being individuated or distinguished from one another in a way that would make their distinctness from one another independent of objects. I don't know whether that's sort of, I mean, it's a very general and
Well, in
vague question.
the case of Martin, you could certainly say that concepts are different if they have obvious or clearly incompatible implications. Now that raises the question: how do you compare them? How do you say that these implications are
I think part of my
incompatible?
question, I mean, you know, as you emphasise, for Frege, concepts are something in the realm of reference, rather than in the realm of sense. And once they're in the realm of reference, then it is quite hard to see how concepts could be differentiated without there being some connection with objects. At least if they were first level concepts, and ultimately for concepts at a higher level.
But
this sort of suggests that what must be involved is some way of looking at concepts which is not quite like that, but thinking of some somewhat more intentional way, perhaps.
I don't think that either of them has a fully worked out view. Although, in the case of Isaacson, since he's published relatively little, a long career, he might have developed a lot of thoughts about these things that he hasn't put into print. I hesitate to say that about Martin because, except for an early essay about the continuing problem from the 70s, all of the philosophical writings that I know about date from the mid-90s or later, so rather late in his career. So I think there are a lot of questions just like the one that you raised that he might just not have a developed view about. Even without pressing the idea of mathematical object in a philosophical way, you might say, well, clearly that the concept of the universe of set